right, guys, we're still looking at our Unit 3 review here, and we're going to move on to question 3 and then go into some applications. So question 3 is focusing on that first step of elimination. Now, we don't focus too much on elimination just because substitution is going to be more widely used in the reoccurring maths after Algebra 1. But if I'm looking at this system of equations, I've got 4x plus 9y is equal to 4, and 6x plus 18y is equal to negative 2. I want to eliminate a variable. I'm going to look at my coefficients currently. For my x values, I've got the coefficients 4 and 6. Now, 4 and 6 do have a common factor of 2, but their common multiple is not up until 12. So that means I would have to multiply the top equation by a 3 and multiply the bottom equation by a negative 2, which is a lot of work. I would have to do a double first step. So let's move on to the second variable. I've got my y variable. I've got 9y and an 18y. On the top, if I multiply that top equation by a negative 2, that would then change that 9y to a negative 18y, and we could then eliminate our y variables. So let me just show you what I just did. If I multiply the top equation by a negative 2, that then becomes negative 8x minus 18y is equal to negative 8. And if I solved using substitution, I could add the two equations together. That would give me negative 2x plus 0y is equal to negative 20. So that middle variable then cancels out. So if I'm looking through my answer choices here, so this is just a multiple choice problem, I would need to multiply the first equation by a negative 2. That would be our correct solution here. All right, let's move on to some real life applications. So we're going to look at question 5 on our Unit 3 test review. It says Jessica has $37 in her wallet. She knows she only has $1 bills and $5 bills in her wallet. If she has a total of 9 bills in her wallet, how many $1 bills and $5 bills does she have? So I've got to isolate my two unknowns. And in this case, that's going to be my $1 and $5 bills. I know she has some bills in her wallet, and I know how much money she actually has in her wallet. I just want to know how many of each type of bill she has. Now, you can choose whatever letters you'd like for your variables. I'm going to be honest, I'm not going to use a 0 or a O for 1 just because that does look so similar to a 0 in math. So I'm going to keep it pretty basic, and I'm going to say that X is equal to the number of $1 bills and I'm going to say that Z is equal to the number of $5 bills. Now, I've got two things going on here. I know, first, she has a total of 9 bills in her wallet. So I could say X plus Z is equal to 9. This equation represents the total number of bills. Then, if I look for what else is given to me, I know she has $37 in her wallet. Well, I know that each $1 bill is worth $1, so I can say 1x, each $5 bill is worth $5, so I could say plus 5z is equal to $37 total. This is the total value of the money in Jessica's wallet. Well, I've now got two equations. I've got x plus z is equal to 9. And because it has a coefficient of 1, I'm just going to write the second equation as x plus 5z is equal to 37. And I'm going to solve these using substitution. In order to do that, I need to isolate a variable first. It doesn't matter which one we choose, x or z. We can solve either one first. I'm going to look at that first equation and subtract a z to start off with. So that's going to give me a new equation, x equals 9 minus z. I'm then going to replace this value with x in the second equation. So I have 9 minus z plus a 5z is equal to 37. Since the x had a coefficient of 1 in the second equation, I don't need to distribute anything. So I can combine negative z plus 5z to give me 9 plus 4z is equal to 37. I can subtract a 9 from each side. And by doing so, 9 minus 37 is 28. Or 37 minus 9 is 28. So that gives me that 4z is equal to 28. I can divide both sides by 4. So z is equal to 7. That means I have 7 $5 bills in the wallet. Or Jessica has 7 $5 bills in her wallet. Then I can use that value and replace z in the first equation. So I've got x is equal to 9 minus 7. 9 minus 7 is 2. So that means she had 2 $1 bills in the wallet and 7 $5 bills. I can check myself. 7 times 5 is 35. 35 plus 2 is $37. And 2 plus 7 does equal 9. So I've got the 9 bills accounted for, and I've got the $37 accounted for. I am done solving that system. Now we're going to go to old Billy. And Billy's on his farm. On Billy's farm, he's got sheep and chickens. He has a total of 22 animals on this farm. Combined, his animals have a total of 64 legs. We're going to assume that these animals are normal animals, so the sheep have 4 legs and the chickens have 2 legs. I need to know how many of each animal does Billy own. So my unknowns, which will be my variables, are going to be my sheep and my chickens. So let's just go ahead and define these variables. I'm going to say that S is going to be the number of sheep. Now I got to be very careful when I write an S because my S's also look like 5s. So just be mindful of the variables that you choose. So S is the number of sheep. And then I'm going to say that C is equal to the number of chickens. Now, this problem tells me that Billy owns 22 animals. I know on his farm he only has sheep and chickens. So those 22 animals has to be some number of sheep combined with some number of chickens. So I can write that equation as S plus C is equal to 22. I also know on this farm there are 64 legs in total. But I was told that sheep have 4 legs and chickens have 2 legs. So I can say 4S plus 2C is equal to 64. I've got 2 equations. I can now solve this system of linear equations. So I have S plus C is equal to 22. And 4S plus 2C is equal to 64. It does not matter which variable you choose to solve for first. I'm in the mood to solve for chickens, so therefore I'm going to subtract S on each side of the first equation to isolate my C variable. So C is going to equal 22 minus S. I am then going to substitute this value into the second equation wherever I see a C. So I have 4S plus 2 multiplied by 22 minus S is equal to 64. Now, because that C did have a coefficient in the second equation, I need to use the distributive property. So I'm going to take the 2 and distribute it to 22 and the negative S. So that's going to give me 4S plus 44 minus 2C, or 2S, is equal to 64. I now can combine like terms. 4S minus 2S is going to give me 2S. Plus 44 is equal to 64. I can subtract a 44 from each side. So I get that 2S is equal to 20. And then I can divide by 2 And that tells me that S is equal to 10. So there are 10 sheep on this farm. But now I gotta know how many chicken are on the farm. So in order to do that, I'm going to replace the S in the first equation with 10. So I've got C is equal to 22 minus 10. So therefore, there are 12 chicken on this farm. If I add those together, 10 plus 12 does give me 22. 4 times 10 is 40. 2 times 12 is 24, and 40 plus 24 does give me 64 legs in total. So these numbers do indeed create the solution for this system of linear equations. While we're here, let's go ahead and look at problem 7. And just so we have a better idea of what our solution is, remember this is the intersecting point for this system of linear equations. So this question says, what's the solution of the system of equations in the given graph? Guys, all you have to do is figure out where their point of intersection is. And in this case, it would be C, because I went right to and up to the point 2, 2.